All right, today we are looking at graphing linear equalities, and that's what you're going to be able to do with two variables. So let's look at a few definitions real quick here. Boundary is the line that splits the true side from the false side. So basically you're going to have some sort of line that's going to be graphed, and on one side you're going to have dots that will be true if you put them back into the inequality, and they will become true statements. And then the other side, if you tried these points over here, they would be false. They would not work into the original inequality. Then we will have a half plane. Now with this half plane, we're looking at two sections, and it'll be, again, a true side and a false side. So basically, again, having that same side, you'll have a true side and you will have a false side based on your test points. So let's look at these. You have basically three steps to follow when graphing these things. So what we'll do is we'll graph the line using the slope and the intercept, and we're going to be looking at an inequality, and then you're just going to put it into y equals mx plus b form, and you're going to come up with the slope, and you're going to come up with the b value. Now another thing to look out is less than or greater than will be a dash line, and then less than or equal to or greater than or equal to will be a solid line when you graph it, meaning it also includes that line. So you can see them over here off to the side again. Third, you're going to pick a point that's not on that line, so some sort of x and y value, put it back into the inequality and see if it's true. Now if it's true, you're going to shade that side, and if it's false, then you're going to shade the other side of that test point. So let's look at this thing. Y less than opposite of x plus 3. Now we're going to graph it as if it is y equals mx plus b, so minus x plus 3, where the slope is -1 and the b value is 3. So we'll start at 3, put a dot, and then the slope is -1. That means down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1, and so on. Before connecting all these dots, I'm going to determine if it's a solid or dash line. Since it is a less than, that means it's going to be a dash line. So I will connect these dots with a dash line. Now we're going to pick a point that's not on there, and you can test an infinite number of possibilities. I'm going to just usually go with 0, 0. So testing 0, 0 right there. So putting 0 and 0 into the original. So if I looked at the original, y less than opposite of x plus 3, and I'm putting 0 in for y and 0 in for x, so 0 less than opposite of 0 plus 3, I get 0 is less than 3. Now 0 is smaller than 3, which is a true statement. So this dot right there is a true statement. That means if I would have chosen any other spot on this side, these all would have been true statements if I put them back into the original. Likewise, if I would have chosen anything over on this side, these would have all been false or untrue as far as the inequality. So last thing that we're going to do is we're going to shade the side that is true. So shading this side like so. So again, this is the true side. So every dot that you try will work if it's in this shaded region. All right, next one. If I graph y less than or equal to x minus 2, my slope is 1 and my y-intercept is -2. So I'm going to put a dot at -2 and then go up 1, right 1 from that dot. So up 1, right 1, up 1, right 1, up 1, right 1, and so on. And since it is a less than or equal to, that means it's a solid line. So I will create a solid line. Again, I'm going to test a point 0, 0. So if I test 0, 0 into the original, y less than or equal to x minus 2, putting 0 in for y, 0 in for x, I get 0 is less than or equal to -2. Now 0 is actually not less than or equal to -2, so that's a false statement. So I'm going to put an F by 0, 0. That makes this the false side, and this side the true side. So any dot that I would try over here would be true, and I'm going to, instead of putting a dot for every possibility, I'm just going to say every dot is spoken for in that shaded region. Last one, this one here, I'm going to graph it as if, I'm going to graph it as if it is a minus 3x plus y equals 1. And if I add 3x to both sides, I'll have y equals 3x plus 1. The slope is 3, the y-intercept is 1, so put a dot at 1, and then go up 3, so 1, 2, 3, and over 1, up 3 and over 1, up 3 and over 1. Now this is greater than, that is going to be a dash line, so I will connect these dots with a dash line. And then I'm going to test a point. Now on this one it's 0, 0 may or may not be, so I'm going to test a point. Let's try this point right there, which looks like it's 4, 2. I'm going to try 4, 2 in the original. So negative 3x plus y greater than 1, and I'm going to put 4 in for x, 2 in for y, so a negative 3 times 4 plus 2 is greater than 1. So I get negative 12 plus 2 greater than 1. I get negative 10 is greater than 1. Now 10 is actually smaller than 1, so this is a false statement. Since it's a false statement, that makes this dot false, that makes this whole side false, and remember that line divides false side from true side, so this must be the true side. So shading the side that is true, like so. And there you go.